Hi guys, welcome to Simplified Education. Today we will discuss a new chapter, that is thermodynamics, which is a very important subject for mechanical engineering and chemical engineering. So I have divided the chapters of thermodynamics such as basic concepts, where we will discuss the system, surroundings, energy interactions, different types of systems, different types of substances. Next, coming to zeroth law of thermodynamics, that is the measure concept of temperature measurement. Next is first law of thermodynamics, followed by its application, that is steady flow processes. Next one is second law of thermodynamics, which is the introduction to the entropy, and we will discuss the entropy in detail. Next concept is mixture of ideal gases. After that we will study properties of pure substance, and at last we will discuss the thermodynamics relations. So I have divided each module of thermodynamics. I will slowly cover all the chapters in detail. Okay. So before coming to the first chapters, I want to just give an introduction about the term named as thermodynamics. So thermo means the energy, it can be heat or work, and dynamics means interactions or transfers. So study of energy and energy interaction is named as thermodynamics. This is the definition and it's very simple. So moving to the first chapter, that is basic concepts of thermodynamics. The first term is used as the system. System is something where our study is focused. That can be a mass, or it can be a space, or it can be a volume. Where our study is focused, that is named as system. Surroundings, anything outside the system or anything external to the system is named as surroundings. Universe is the summation of system and surroundings. The separation between the system and surrounding is named as boundary. So I have given a diagram over here. If this is the system where our story is focused, outside the system is surroundings, and togetherly it is called as universe. Okay. Another one important thing I want to tell over here is boundary can be fixed, can be moving. If the system is moving, the boundary is moving. If the system is fixed, the boundary is fixed. Next, coming to the different types of system. So the first system we call it as open system. So what is the characteristics of open systems? We will discuss it. The next type of system we will take it as closed system. Another one is, third one is isolated system. Okay. Next, coming to the energy interactions, in which system we are having energy interactions, in which system we are having mass interactions. So in open system there is both energy and mass transfer. Okay, this is the energy interactions, this part is the energy interactions part, this part is the mass interactions part. So in open system both energy and mass can be transferred. The example, if I will tell you, that is the turbines, compressors, pump, boiler, nozzle, diffuser, etc. So turbines, compression, both are having a inlet and also an outlet. Through the inlet the gas or fluid has to enter, and through the outlet it has the exit. Next, coming to the closed system, there is energy interactions but there is no mass interaction. The best example for the closed system is refrigeration plant. What exactly happens in refrigeration plant is, there is a refrigerant, or you can say it's a coolant, which transfers through the pipes and tubes. So it gives refrigeration effect. After that the mass does not change, but the cooling effect is there So we tell that energy interactions is present but mass interaction is absent. So this is an example, best example of closed system. Next I will say piston cylinder arrangement. I think everyone knows this. Piston cylinder arrangement. Excluding valves. You should note this point, that excluding valves. Why I am telling excluding valves is, you know, an IC engine, right? So in IC engine what happens, the inlet through the inlet port the gas entries to the system, but if the valves are not there, it behaves as a closed system because there is no inlet, there is no exhaust, only the interaction which is present is the heat interactions or energy interactions. Next thing is the isolated system. So in isolated system what happens, no energy interactions, no mass interactions. The best examples you know is thermoflask. So what happens in thermoflask, you store hot water in there or cold water. So hot water temperature is maintained. Why the temperature is maintained? Because there is no heat interactions or energy interactions, you can say. Okay, now we will proceed to the next concept, that is microscopic and macroscopic approach of thermodynamics. So what is that? So in microscopic approach in thermodynamics, I will just give a brief introduction about this. That is, in microscopic and macroscopic approach. In microscopic approach of thermodynamics, the behavior of individual molecule will be taken into consideration. So in microscopic approach, another one is macroscopic approach. So in microscopic approach, we consider each and every molecule, but in macroscopic approach what happens is the behaviors of individual molecules will not be taken into consideration, but the average behavior of the molecule will be taken into consideration. So it is otherwise named as classical approach. That means we neglect the intermolecular distance present between two molecules. Okay, we neglect the intermolecular distance present between two molecules. That is the macroscopic approach. Another one is microscopic approach. Okay. So I should say one important points over here again. One is in macroscopic approach. Now onwards there is no microscopic approach in thermodynamics. So the assumptions now we made is macroscopic approach. Now onwards we will discuss only the macroscopic approach, because you cannot consider each and every molecule in a system. If you are going to consider, then you cannot cover the whole system, because an system has an infinite number of molecules. So we will directly go to the macroscopic approach, or which is named as classical approach. In macroscopic approach, I have already told you the intermolecular space is very less. That means we can neglect the intermolecular space. This is one point. And the next point is the mean free path can be neglected. What do we mean by mean free path? Mean free path is the path or the distance between two molecules when they are going to collide with themselves. So this is the mean free path. So mean free path can be neglected. or we can otherwise say it as a system is continuous. Okay, so these 2 points are the major points of macroscopic approach. Now onwards, whatever we will discuss for the system for different kinds of processes, macroscopic approach is the assumptions. You should note this point. From now onwards, macroscopic approach we will use very frequently. That means whatever things we are discussing, that means it is based on the macroscopic approach. Now coming to another point, that is thermodynamics equilibrium. So what is thermodynamics equilibrium? For a system to be in thermodynamics equilibrium, it has to be in thermal equilibrium, first point. Next point is it has to be in mechanical equilibrium, and it has to be in chemical equilibrium. If the system is in these three equilibrium, then we call collectively as thermodynamics equilibrium. So in thermal equilibrium, the temperature difference is not there. That means equality of temperature is present. In mechanical equilibrium, equality of forces and torques are present. And in chemical equilibrium, no chemical reaction occurs in a system. So these three processes are there. So for the thermodynamics equilibrium, the system has to be in three different equilibriums, that is thermal equilibrium, mechanical equilibrium and chemical equilibrium. And one major point is system is analyzed only when it is in thermodynamics equilibrium. Okay, a system can be analyzed, whatever system we are going to analyze in the next coming chapter, in that case the system is in thermodynamic equilibrium. Now coming to the pure substance, so I will give a brief overview of pure substance over here, but we will discuss the properties of pure substance chapter here. I think this is the 6th chapter, we will discuss later. So what is a pure substance is if the substance is having a homogeneous, that is same chemical compositions, and another one is same chemical aggregation. That means the number of elements present in the ratio will be same for both the cases. I am taking one example of water in steam and water that is the normal conditions, that is liquid. So this is called as pure substance because the presence of hydrogen and oxygen ratio are same, that is 2:1 in both the cases, but and the bondings are also same. But in these cases what we can see, H2 plus O and H2O, this is not a pure substance. Although the ratio are same, this is not a pure substance because the bonding, that is the chemical aggregation or the bonds between the elements are not same. That's why we call it as a impure substance. Another exception is there, that is air. Air can be dealt as a pure substance, and air is in various composition of pure substance. That means different pure substance are mixed together to give another pure substance, that is named as air. Although it is an exception, we take it as a pure substance. Next, coming to the properties of the system, we classify the property of the system into two categories. One is extensive properties, another one is intensive properties. In case of extensive properties, if a quantity depends on mass and size, like energy, kinetic energy, the formula is half mv square, that means it depends on mass. Mass also itself is an extensive property. volume, entropy, all these are categorized into extensive property. Another one is intensive property. So in intensive property, if I consider a room, in a room the amount of substance you kept does not depend on pressure and temperature. If you increase the amount of substance or weight of the substance, it does not affect the pressure and temperature in that room. That means it is constant. So these are the two types of property of the system. Next, coming to the specific quantity. But the thing is, if that is in condition, if the specific quantity means if an extensive property is divided by another extensive property, we call it as intensive property. So this is a specific quantity. That means I am taking one example like kinetic energy. Suppose in kinetic energy the formula was half mv square. If I will divide with an extensive properties that is named as mass, then mass will get cancelled in numerator and denominator. We will get only velocity, and I have already told you that the velocity is an intensive property which never depends on mass or size. So specific quantities are intensive properties. Now some important points about the property of the systems are: properties are independent of past history. That means whatever happened in the past, it does not make any sense to any property. Next is exact differential. I think you have studied this in the differential equation. What are the exact differential and inexact differential? Okay. Next, coming to the path independent or point functions. Whatever the path followed by the system, it will not follow. A property only depends on the final points of the path. That means it's a point functions. Next, coming to the processes, types of process. There are two types of processes. One is reversible, another one is irreversible. Suppose this is a pressure volume diagram for a processes. For reversible processes, at one point, suppose at this point, this is pressure, volume, temperature, and at this point, this is again pressure, volume, temperature. Okay, this is P1, V1, T1, this is P2, V2, and T2. So from P1 to P2, V1 to V2, T1 to T2, this is a forward reaction, and it has the capability to go to P2 to P1 as it is in reversible reactions. So what is reversible reaction is? A process is said to be reversible process when it reverses its direction by the same path as that of the forward direction. Okay. But practically we see that all processes are irreversible process because of the friction, as in practical life friction is present everywhere, which makes the process irreversible. Okay. Next, coming to an important concept, that is quasi-static process. So what is a quasi-static process? Suppose this is an chamber where this is an, we know piston cylinder arrangement, this is an cylinder, this is an piston. Okay, we are keeping some blocks over the piston slowly, like I have placed one block over here. Okay, then I am going to place, I have placed one block for some time. After it has reached equilibrium as the initial, again I am placing another block slowly, again I am placing another block slowly. Suppose I am placing infinite number of blocks over here, but the state of the system, that is pressure, volume, temperature, negligibly changes. That means we can tell that that system is in equilibrium. It goes from P1, V1 to T1, and it is to P2, V2, T2. It is goes from this P1 to P2, but all the points in between these are equilibrium. So this is pressure volume diagram. So a process carried out in a differential manner, and in case of quasi-static process, the system remains in thermodynamic equilibrium at each and every point. You should note this point. It is in thermodynamic equilibrium okay. Next, coming to the last basic concept of this chapter, that is Gibbs phase rule. In Gibbs phase rule, there is a formula that is equal to F equal to C minus P plus 2, okay, where F is the degree of freedom, C is the number of components, P is the number of phases, okay. So suppose I am considering O2 as my system. So what will happen? Phase is 1 because it's in gas, component is also 1, so the degree of freedom will be 1 minus 1 plus 2 and it will be equal to 2. This you can calculate the degree of freedom. You know, I think there is some other examples like in material science you will study different processes like eutectic, eutectoid. All those processes are related to this Gibbs phase rule, which gives a degree of freedom 0. In that you will study that material science, eutectic, eutectoid. I will take another example such as water and steam. So what are the number of components and what are the number of phases, okay, and what is the degree of freedom? The number of components we have is 1, number of phases is 2, so degree of freedom will be 1 minus 2 plus 2, that is equal to 1. So in this case the degree of freedom will be 1. The component is 1 because H2O is water, H2O is again steam. The composition is same, that's why the component is 1, but the phases are different, that's why we have taken 2 phases, so the final degree of freedom will be 1. So now I am completing these basic concepts over here. Now we will study next the 0th law of thermodynamics, which is major consequences about the temperature measurement.